Let's solve a basic trigonometric equation that has tangent in it. So we're going to solve tangent theta equals root 3 over 3. Root 3 over 3 is a pretty familiar value for tangent. You might remember that pi over 6 has tangent root 3 over 3. So it's pretty easy to find one solution for this equation, but remember, to solve an equation we need to find every solution. So let's draw a most important diagram and think about what other solutions there might be. Okay, so root 3 over 3 is going to give us a line with slope something like this, and pi over 6 is this angle. Now, as with sine and cosine, you can add any multiple of the period of tangent, and that won't change the output of tangent. So that would give us another solution to this equation. So we can add any multiple of the period of tangent. But remember, the period of tangent is actually pi and not 2 pi. So we'll add pi k. All right. Now on the most important diagram, tangent is a slope. So this red terminal side is one way of getting slope root 3 over 3. But if we go in the opposite direction, there's another way of getting slope root 3 over 3. So how would we get this green terminal side? Well, we could start with the red terminal side and then add a half turn like this. And a half turn is pi, so that green terminal side would be pi over 6 plus pi. But we actually already have this solution written down in our previous list, pi over 6 plus pi k. So there's no reason to add this to our list again, so we already have this one. So for tangent, there sort of isn't a symmetric solution like there is with sine and cosine. Let's see why that happens in terms of the graph. If I can draw the graph a little bit straighter than that. Here we go. So tangent looks like this. Whoa, I'm doing a really bad job. There we go. And then it repeats. Like this. And we want root 3 over 3, which is something like that. Maybe I should draw one cycle to the left. Okay. And our red terminal side up there, it gives us this first intersection. And then when you add pi, well, since pi is the period of tangent, you get the corresponding point on the next cycle of tangent. And by adding 2 pi, you get the corresponding point on the cycle after that. By subtracting pi, you get the corresponding point on the cycle before. And you can see there aren't any solutions that we've missed. We've already taken care of every intersection point of the graph of tangent with this horizontal line at height root 3 over 3. So there aren't any other solutions. There aren't any symmetric solutions for tangent. Or another way of thinking about it is it's almost as if the period of tangent is 2 pi, but then the symmetric solutions fill in the gaps in 2 pi to make the period 1 pi, kind of. So anyway, one way or another, for tangent it's a little bit simpler than sine and cosine. Once you have a principal solution, you just add pi k and that gives you all of the solutions.